Okay, the last VI graph we've got to draw, the last potential difference current graph, is using this component here. This is a diode. Okay, you need to know the symbol for a diode, and I've drawn one there. You also get light emitting diodes that look like that, LEDs, but I decided just to use a normal diode for this one. Now, you're probably not going to do this in class. The reason is that you've got to limit the amount of current to go through the diode, and it's quite tricky to check that everybody's got that done. So I've set up a slightly different circuit here, but it's going to give the same results, and you could use the same circuits that we've been doing about. However, you have to be a bit careful when you're actually doing this in practice, because too much currents going through the diode would damage it. So if I just turn it off to start with, okay, and we're going to again be recording potential difference, and we're going to be recording current. And this is, as I said, for a diode. This is the circuit I've set it up. You won't need to know the circuit. You can just do the circuits that we've done for the resistor and for the bulb. But when you're looking at A-level, this is the sort of circuit that we'll start looking at, okay? So I'm going to get some results, and you can use my results to be able to graph. So if I turn this on, I've set this at 2 volts. I'm not going to go above 2 volts. So all I'm going to do is I'm going to change my variable resistor, and I've got about 0.6 volts to be my first reading. So 0.16 volts gives a current of 0. Okay, most people get worried when this happens. Have they done it wrong? Should we not have a current? Okay, I'm going to change that up a little bit then, and I've got it up to 0.28 volts, also gives a current of 0. So I'm going to change it up a bit more. And we've got here 0.52 volts is giving a current of 0.04 or 0.05, okay? Changing it up again. So we've got 0.6 volts or 0.59 volts gives 0.16. Okay, so 0.59, 0.16. Increasing the potential difference a bit more. We've got 0.64 volts and 0.48 amps. I'll see whether I can increase it any more. It looks like 0.64 is the highest number I can get. So having a look at my results, I probably want to get some more results there just so I can see a pattern. I'm going to go for something in between 0.28 and 0.52 to see whether I've got something different happening there. So 0.47 gives us 0.02. So 0.47 gives us 0.42. Oh, sorry, 0.02, not 42, 0.02. And I'm going to see whether I can decrease the potential difference a bit more till we get a definite 0.01. So that's at 0.43. I've got it to be 0.01. Now, looking at these results, I want to get something in between the 0.16 and 0.48. So I want something between 0.59 and 0.64. .61 is 0.22. And I'll see if I can get just a slightly higher one. .62 is 0.29. I'll put that at the bottom. 0.62, 0.29. Okay, so you've got lots of results there. It should be 0 up until a point, and then we should see an increase. Remember, these last ones I just put in because I didn't want you just to have 4 results there. So when you copy it out, you might want to put them in the right place so you have the potential difference getting bigger. Now, let me just show you something before I put this away. I'm going to take that, put that all the way down so the potential difference over it is 0 again. Then what I'm going to do is I'm going to switch around these connectors. I'm going to turn my diode around, okay? I'll pop those back in, so it's just the same circuit, but I've swapped the diode around. Now I'm going to change the potential difference, and I'm going to have a look and see what happens to the current. As you see there, I've got a potential difference of 0.97 now. The current is 0. I can increase that potential difference even more, 1.55. The current is 0. You don't get any current whatsoever in the opposite direction. Okay, so diodes, that's what they do. That's one of their characteristics. It only lets the current go through in one way. The current won't go through in the other direction. So if you want to plot a graph, please, of potential difference on your x-axis, current on your y-axis, have a look at the shape of the graph. Think, though, if you were plotting this and you were having potential difference on your y-axis, sorry, your x-axis, and you were going from 0, we've got to go up to 0.64. Okay, so you go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. What would the graph look like in that direction as well, in the negative direction, when we've got a negative potential difference? Because we've said that our current in the negative direction is 0. So when you draw it, could you have a bit in the negative direction at 0? It carries on at 0 on this side until we first got something at 0.43, so it goes along at 0, and then suddenly we've got absolutely loads, so it goes up like that. So try and plot these results on the graph for me, please.